Moodle site, you'll find this under test prep. So notice in the left-hand column, we're going to have each of the different types of equations. Some of these we've already covered, but today we're going to cover some new types of equations, and we're going to cover how to solve inequalities. And so this middle section here is for you to write your strategies for you yourself, write your strategies for how you would solve this type of equation. And then over here, you can actually throw in an example. Now you're allowed to bring in one 8.5 by 11 piece of paper for your test on Monday, as long as it's your writing. You can't be Xeroxing anything out of a book. And some people say, well, could I put it into Microsoft Word and type it? I don't care, as long as it's your work. Okay, so what a lot of students do is they fill this in, which is going to be a big section of your test, which is solving equations. Then they flip it over and they write their notes for the rest of the material, the other couple of classes that were covered other than this. So that's up to you, whatever you want to do. But I would use this as to start filling this in right after class today. Start putting in examples. This will help you for your quiz on Wednesday as well. So that's just in your Moodle. Print it out. If you have problems printing it, I'll be glad to do it for you. I want to talk a little bit about your quiz on Wednesday. If you are a habitual late starter coming to class, you're going to miss out on a golden opportunity. And I'm not talking to anybody in particular. You have to be here at 10:40 on Wednesday if you want to participate in what I call the group quiz. The quiz on Wednesday is all going to be done in class, but it's done in 2 parts. You'll have 35 minutes to do the group quiz, and then 35 minutes to do the individual quiz. 35 minutes for the group quiz starts at 20 of, unless your entire group is here early and you want to start. So you have to work that out with your group mates. The other thing is, I am not defining what a group is. You notice, I didn't say your table, I said a group. So you have to think about that. I didn't tell you what size the group is. So a group quiz is 35 minutes, and then it all gets handed into me, and then you have an individual quiz that's very similar to the group quiz. It's not identical, and it's not just changing numbers. It's similar. So there's some almost identical exercises and some that are a little different. So the goal is that you work with a group, or you work individually within a group, however you work. That kind of is like your warm-up part of the quiz, and then you get a quiz right after that you work individually. Alex? I said I didn't tell you how big the group was. Okay. Yep. Excuse me? What? No. You get the individual quiz after the group quiz has been passed in. No. No. Other questions? All right. So that's Wednesday. Friday's a review, and Monday's your first test. Any questions on what's happening this week? Okay. All right. So we sort of have, unfortunately, a long sort of a lot of details today. Oops, what happened to our notes? A lot of class demo today. So you're going to have, and they say, oh, I can divide both sides by x squared. When you do that, you're losing one of your potential solutions. And sometimes you're actually dividing by 0 if x happens to equal 0. So you never want to try to simplify an equation by literally dividing both sides by a variable or a variable expression. All right? So what you want to do is you say, okay, what have I done with polynomial equations before? Well, one polynomial equation that you've solved is a quadratic. We don't give a fancy name to this equation. We just call it polynomial. Quadratics and linear equations come under the umbrella. Here's your umbrella. Isn't that cool? Polynomial equations. Okay, we give special names to linear equations, which is the first degree type of equation, and quadratic. After that, we just throw them in the category of polynomial, but they're all polynomial equations. So the idea here is you're going to borrow strategies. Everything we do today, we're going to borrow strategies from both solving quadratic equations and linear equations, and we're going to kind of make combinations of those strategies. So here, when you see a polynomial equation, you first have to identify that that's what you have. So anytime you see an equation with higher powers other than 1 and 2, you know it comes under this category. And the key here is to set your equation equal to 0, just like you do with your quadratic equation. So I'm going to subtract 6x squared from both sides. Notice I start off with an equation. My very next step is an equation. You're going to get tired of me saying this, but it's to make a point. Now you say, what the heck am I going to do with that? We don't have any property of math that tells us if we have some number when we raise it to the 4th power, and then we have that same number and cube it, we add them together, and then we subtract 6 minus that number square and get 0. That we don't have anything that's going to help us figure out what x is here. But we do have something that will help us figure out what that is if we can turn that adding and subtraction problem on the left side into a multiplication problem equal to 0. So one of the things is, can you factor this? Is the left-hand side factorable? And you say, yeah, I see my GCF is x squared. So when you pull that x squared out, you have x squared plus 1x minus 6 left equals 0. Again, you write an equivalent equation as you go down each step. Now you're getting there. X squared can't be factored anymore. You could write it as x times x, but that's, not going to give you much information. But you now look at your second factor and you say, can I factor that? And you say, if I can, it's going to be 2 binomial factors. So I'm looking for factors of 6 that differ by 1. And the factors of 6 that differ by 1 are 3 and 2. And now I have to have my middle term be plus 1x, so I put my addition sign in front of the 3 and my subtraction sign in front of the 2. So notice you do have the same number of factors here as that exponent. 4 is your exponent. You have 1 factor, 2 factors, and there's 2 factors right there. They just happen to be identical twins. So you got 2 factors here, 3 and 4. So notice you potentially have, when you solve an equation like this, you potentially have 4 solutions. Sometimes they're identical. So you set each factor equal to 0. And this is the one case where you have a quadratic equation where you have one answer, is when your square is equal to 0. Then you set this factor equal to 0. Notice an equation solved by equation, solved by equation. X equals -3. And then finally, this factor, x minus 2 is 0. X equals 2. So you have 3 solutions. You actually have 4, but one of them is a twin, 0. So you have 0, -3, and 2. And when you put this into my math lab solution set, you start with your smallest number, then your next number, and then your largest number. And that's your solution set. Any questions on that? Okay, so let's take a look at our exercises real quick. We've got a bunch of equations starting here. Can we identify the polynomial equations in exercises 1 through 9? Are there any polynomial equations from 1 through 9? No, they're not all, because a polynomial equation, the exponent has to be 0, 1, 2, 3, 4, 5, 6. It has to be an positive integer. Okay, so this one doesn't have an integer. It has a fraction for a power. So not all of them. 4. What about number 1? What about number 1? Number 1 is a polynomial equation. So you're going to use the strategies we just learned on that. Please don't do it right now. 4 is an absolute value equation. That's an absolute value. Anything else? 6 and 6, correct. So polynomial equations 1 and 6, we'll use the strategies we just discussed. Okay, let's take a look at number 2 now. Number 2 is called a radical equation. And as my 16-year-old would say, she'd go, duh, right? She'd say, Mom, come on, radical, you see the radical? It's a radical equation. I don't like it when people say duh to me, because when I was growing up, I confused it with duh, which always made you feel like, you know, you were not part of the normal sort of personnel. But who wants to be normal anyway? All right, so radical equation, you see a radical, right? Not too hard to find. Here we're going to use the strategies we use first for the idea of linear equations, which is when you're trying to solve a linear equation, whatever your variable is, you try to get it on one side of the equation and your numbers on the other side. And you always want to get 1 in front of your variable to solve it. Same is true here. You want to isolate the radical. Okay, you want to isolate your radical, and that just means get your radical on one side with a coefficient of 1. Well, there's nothing to do here because that already has a coefficient of 1 on the outside of the square root of x. So you subtract x from both sides. Okay, so step 1 is you've isolated your radical. That's done. And now you have to undo the square root. And so you want to undo the square root sign by squaring both sides of your equation. So if I square a square root, they're inverse operations and they undo each other, and that just leaves you with the variable x on that side, which is exactly what you were hoping for. What does x equal? Right? But when you square the right-hand side of the equation, you have a binomial square. So this is not 144 plus x squared. Hopefully by the time you leave Math 107, you won't make that mistake anymore. And if you have to, just write it out the long way. 12 minus x times 12 minus x, and use your distributive property twice, or use the box method if that's what you learn. When you square that binomial, you get 144 minus 24x is your middle term plus x squared. Okay, so you've done that. You've squared both sides. And now what type of equation do you have? It's polynomial, and it's a special polynomial with a special name, quadratic, right? So now you have a quadratic equation, and you have several methods for solving this, whatever one you want, but the key here is you have to subtract 1x from both sides, get a 0 on this side, and you get 144 minus 25x plus x squared. Okay, any questions there? I'm just rearranging it because I like to see my x squared term first, keep my middle term where it is, plus 144. Now you can either solve this by using the quadratic equation with these values for a, b, and c, and you can do that now, or you could factor this. And to factor this, you're looking for factors of 144 that add up to 25. So here's where a little common sense comes into play. You're not going to use the factors of 144 that are very far apart, all right? Like 1 and 144. That's going to add up to 145. You're looking for factors that are relatively close in size. So you can use various, so those of you who want to use the quadratic equation, get going right now. You can do that. And those of you who would like to do a little much more with factoring, I'll show you how to sort of get started here. So you want to look for factors that are relatively close in size. So a few things that can help you out is some of the rules for dividing numbers. If you add up 1 plus 4 plus 4, if you add up the digits, notice what number you get, 9, which means 3 divides into 144 and 9 divides into 144. That's where I'm going to start. I'm going to divide this 3 into 144, and I'm going to get 48. Is that right? 3 into 144? And now I'm going to try 9. 9 goes into 44 16 times, and look, boom, I'm done. So that's how fast this can be factoring when you know a few little tricks of the trade. And so x equals 9 and x equals 16. I don't know if you're done yet with the quadratic. You might still be working it out, but you should get the same results. As long as it's factorable, yes, you can use those little we call them divisibility rules. When is a number divided by 3, by 9, by 6, by 4? There's like little rules that you know if it ends in 0, you can divide it by 5 and 10. You know if it's even, you can divide it by 2. Yeah. Okay. Huh? All right. However, if I answered the problem like this, I wouldn't get full credit for it. No. And it's something you probably don't know about. Remember, I didn't start off with a quadratic equation. If I started off with this equation, those are the two answers. I started off with an equation that has a smaller power than 2. This equation has 1 for a power and a half for a power. What happens when you square both sides of an equation is you can, not always, you can introduce an extra solution that's false. So it's mandatory on radical equations. This is one thing you should add to your little cheat sheet or your notes is it's mandatory. If you're not in the habit of doing this, for radical equations, you have to do it. You have to check your answers. So let's check our answers. My first answer was 9. So I'm going to put the 9 in and see if the left side equals the right. 9 plus 3 is 12. 12 equals 12. I'm happy. So I can come down here and circle 9. That's definitely an answer. Now I try the 16. 16 plus the square root of 16, does that equal 12? 16 plus 4 does not equal 12. So that's what we call extraneous. That does not work. So that does not work. So your solution set for this equation is just the number 9. So you have to make sure when you do a radical equation that you check your answers. All right? Any questions on solving this radical equation? Okay, the next type of equation we have is rational equations. Oh, excuse me, we've already done rational exponent equations. All right, now the key here is the same idea that we did before. We want to isolate our term that has the rational exponent. Here's our term right here with the rational exponent. So my first step is to add 6 to both sides. Just like I would if that was just 3x minus 6. I would add 6 to both sides. In fact, it's not a bad idea with these rational exponent equations is just to pretend, just fantasize for a few minutes that simply says 3x minus 6 is 0. If you had 3x minus 6 equals 0, you'd add 6 to both sides, and then what would you do? You would divide by 3. It doesn't change. Exactly the same strategy that you would employ if you just had a linear equation. So this is where life gets a little different. And at this point, you can branch out. You can either keep it as a rational exponent, or some students prefer to put this in radical form. That says the 4th root of x. Remember, that's your root, and that's your exponent. So some students like to do this. The 4th root of x cubed is 2. Some students prefer to write it like that, and some students prefer to keep the 3 inside. That's what I would suggest. I would do that. Some students like changing it to the radical form in order to undo it. And some students don't mind seeing this equation solved with a little different approach. So this is what we want. We want x equals some number. We want a solution. What's the power on x right now? And the answer, sorry, in this like imagined answer here, what would be the power on x? 1. So somehow I have to do something to this, to both sides of this equation, so x to the 3/4 turns into x to the 1st. Well, the only thing I can do is I can raise both sides of that equation just like I did back here. With this problem right here, I raised both sides of the equation to the 2nd power. I squared both sides of the equation. Here, I have to raise it to a power that will undo the 4th root and the cubing. So I have to raise it to an exponent that's a fraction as well. So the fraction that I want is some number that when I multiply it by 3/4, I get a 1. Does anybody know what special number that is? 4/3. And do you know what we call that number? It's reciprocal, right? So if you raise both sides of this equation to the 4/3 power, this says, okay, when you raise a power to a power, you multiply your powers, and whenever you multiply reciprocals, you get the magic number 1, which is what you want. And so now your answer becomes 2 to the 4/3, which you can leave it like that if you want. You could call it the cubed root of 16 if you want, because 2 to the 4th is 16. But this is fine, just like that, 2 to the 4/3. It can't be simplified any further. There's no need to write it as a radical as far as I'm concerned. So you just find the magical exponent, which is the reciprocal of the exponent you see. And that's exactly what happens, folks, when you have something like this. When you have the square root and you square both sides, notice these two numbers are reciprocals of each other. They undo each other. They bring you right back to x to the 1st. If you change it to this form, then you undo the 4th root by raising both sides to the 4th power first. This now just becomes another radical equation. You get x cubed equals 16. And now you take the cubed root of both sides to undo the x cubed. And there's no need here, like with square roots, for absolute values or more than one answer, because cubed roots are unique. Take the cube root of number, you get one answer, not 2. So you get x equals the cubed root of 16. So both of these answers are identical. The process to get there is a little different. So you need to do what works for you. I don't know what works for you, but these are the different ways that I've seen students approach this type of equation. Any questions? Yeah, Christine? This to the square root of 2? You could if you wanted to. So what Christine is saying is the cubed root of 16 can be written this way. And I want to show you how you can do it both ways while the radical are here. Is the cubed root of 8 times 2. 16 is the cubed root of 8 times 2. Now you're looking for perfect cubes underneath the radical, not perfect squares. So this becomes the cubed root of 8 times the cubed root of 2. The cubed root of 8 is 2, and the cubed root of 2 can't be simplified any further. So yeah, that would be the final version. Thank you. Now over here, how do you see that same answer? Look at this. 2 to the 4/3 is the same thing as 2 to the 3/3 times 2 to the 1/3. Because when you multiply this, you add your exponents. 3/3 and 1/3 give you 4/3. And look what this is. This is just the number 2. So 2 times 2 to the 1/3. With this, I'm fine leaving it that way. With radicals, you can simplify it. You don't need to write it this way. This isn't any simpler to me than this. All right, so rational equations, again, all the all the steps you've used in your previous equations. It's just usually the fact that you're raising to a fractional power that kind of looks a little weird until you do it a few times, okay? Absolute value equations. Okay, the key to absolute values equation is to get your absolute value on one side, like it always is for any type of equation. In this case, your absolute value is already on one side, the left side. So you have some kind of stuff, the absolute value of some stuff is equal to a number. And this is simply all you have to do, but I want to show you why you do this. You take that stuff and you set it equal to the number you see, and you take that stuff and you set it equal to the opposite of that number. And this is the reason why. I want to show you what this looks like. This says the absolute value of something equals 11. Now what that means is whatever that stuff is inside that absolute value sign symbol, the distance from 0 is 11 units, which means you can either go 11 units to the right of 0 or 11 units to the left, because the absolute value of opposites is equal. Okay, absolute value of opposites is equal because that's how we define opposites. They're the same distance from 0. And absolute value deals with distance, not direction. That's why you never have anything other than a positive absolute value. So now you say, okay, so if I said here the absolute value of x equaled 11, this is what it would look like. My answer would be 11 and negative 11. Well, I don't simply have x inside of that absolute value. I have this expression. But that expression has got to equal negative 11, and that expression has got to equal positive 11. So right below where I would see the negative 11, I'm going to write the expression 2x plus 1. And right below where I see positive 11, I'm going to write the expression 2x plus 1. And now I've got my setup. I know that 2x plus 1 has to equal a negative 11 for its absolute value to be 11. And I know that 2x plus 1 must also equal a positive 11. So there are my two equations to solve. So any absolute value equation will produce two linear equations if the expression inside is linear. And then you solve the linear equation like you normally would. And you get one answer is negative 6. And then you get 2x equals 10 and x equals 5. And then you check your answers. You go back and you put negative 6 in here, and you get negative 12 plus 1 is negative 11. Absolute value of negative 11 is 11. Similarly here, you put a 5 in here, you get 11. Absolute value of 11 is 11. So I would suggest, I've seen a lot of students, you've learned different methods from previous courses. I would strongly urge you to do this little visual for yourself. Whatever the number is here, draw a number line, put that number and its opposite on it, take the expression, put it underneath each one of the numbers and its opposite, each number and its opposite, and then set up your equations. And you really can't go wrong with an absolute value equation as long as you follow that particular method. Questions on this? All right. So I think that's it for equations. So if you're filling out that little paper I showed you, you have every type of equation now. And then the last thing we have to look at before you start your exercises today is inequalities. And inequalities, the only thing you have to remember is that solving inequalities very much follows exactly the same strategies as solving linear equations. The exception being that now when you multiply or divide both sides of your inequality by a negative number, you must reverse this sign, the inequality sign. So in this particular problem, negative 4x is less than 8. You're trying to find all the values of x that when you put it in and multiply it by negative 4, you get a number less than negative 8. So just for the hoo-has of it, let's forget that what the property is of inequalities. If you divide this by negative 4, and you write this because you forgot. All you need to do is check your answer. Pick any number less than -2 and check. So what's a number less than -2? 3 is not, oh, -3. So let's pick -3. -4 times -3, is that less than 8? Is 12 less than 8? No. So you'd say to yourself, oh, this is where I forgot when I divide by a -4, I have to change the direction of my inequality. It's only in multiplying and dividing that you have to remember to do that. So this gives you x, this gives you -2, and now you reverse the inequality. So any number bigger than -2 is going to be a solution for that inequality. And the solution set is infinite. So that's why you have to use one of these notations to show your solution set to an inequality. So you could get out of this really simple. If you want to do set builder, you can go like this. Straight line, x, boom. There's your set builder. You're going to end up with the inequality for your answer. So just put the curly braces, the x, in the straight line, and that's your set builder notation. So the answer to this is x equals, is greater than -2. That's set builder notation. What would the interval notation look like? Does anybody remember interval? X greater than -2? Does everybody agree with that? Can we include -2 here? Let's try. Is -4 times -2 is 8? Is 8 less than 8? No. So what do I have to put instead of a bracket there? Another parenthesis. Because if it said less than or equal to 8, then I'd use my bracket. Okay? So this is interval notation. That's interval. And then if you graph this on a number line, you put -2 with your bracket, and then you shade all the way to the right with a nice big fat line, and that's the number line notation. This is how you have to use sets to give answers to many types of equations. And this is the way you do it. Okay, so, and you're going to be using this when we get to functions, which is the whole rest of the course. Compound linear inequalities. Sometimes you get more than one inequality squished together, just like you can have a compound sentence. I don't think you call them compound sentences anymore, do you? One of my students told me a few years ago, you got some fancy name in English now, like Linda gave her homework to the dog and the dog ate her homework. I put two full sentences together with and. What do you call those now in English? Do you call them compound sentences? No, that's not run on. Anyway, all right. So there's two ways you can treat a compound inequality. You can add the same quantity, subtract the same quantity, multiply by the same quantity, divide by the same quantity. It's just that you have to do it to all three pieces. You're used to just doing it to two sides. So one approach is to say, okay, I want to get x in the middle. And right now, that -4 is hanging around. So I want to add 4. But instead of now saying to both sides, you want to add 4 to each end here and the middle. So there's three pieces you have to add 4 to. You're not violating anything here because you're not multiplying or dividing by a negative number. So you add here, you get -2 is less than x, because that goes to 0, is less than or equal to 1. So you're done. That's it. Oh, yeah, I do mean 5. Thank you. All right. So in interval notation, it looks like this. The -2 is not included, but the 5 is. And on the number line, I put -2 with the parenthesis, and I shade up to 5, and I put a bracket. And then set builder, you just keep your inequality like that. You put your little curly braces. You do x and line. Okay. So any number between -2 and 5, if you put it in for x, will satisfy that linear inequality. Okay, any number on that interval. And it just doesn't mean numbers like -1, 0, 1, 2, 3. It's any number, any real number. And again, if you don't like that, you can break this up into two separate inequalities like this. Just break it up into two pieces and then solve each piece. Some students like doing it this way. So there's one piece. They don't like doing it by keeping it all together. And now you just smush them together. They both have x in the middle here, and you put the less than or equal to 5, the greater than or equal to 2. So you just squish them together to get your final answer. Okay, so you have 20 minutes to work on your class activities. I would look over all of the problems. I would start with the ones you think you'd have the most difficulty with so you can get help while you're in class, okay?